the trig identities. Now we're told to simplify this. Now over here on the right side is the trig identities that we've talked about so far in class. So we're going to have to use something from over here to simplify this. Alright, now the first thing I would do is, I don't have any squareds here, so I'm not going to deal with these. So this, and this, I'm going to leave alone. I don't think I'm going to need those right now. I may need them later, but right now I'm not. So I'm going to look at what's called the ratio one first for tangent. And then I'll probably go ahead and replace secant as well with 1 over cosine. But so I'm going to replace secant with 1 over cosine x. Now the x is just a variable here. It's theta, but since our problem has x, that's what I'm going to use. Minus, now tangent, I'm going to replace this for the tangent. So I'm going to, just like when you did a substitution problem or whatever, we're going to rewrite this as sine x over cosine x. Okay, then we have sine x. Okay, now we have sine x times sine x, so let's be sine x squared. So I have 1 minus sine x squared. Now, since these have the same denominator, I can just write it over 1 as a fraction, like this, simplify the fraction. Now, if we look over here, now that I've got a squared, now that I have a squared, I'm going to look down here at my Pythagorean theorem ones. Now, we've manipulated this before in class, but I know that cosine squared theta is equal to sine 1 minus sine squared. So what I'm going to do is take this and replace that with it. Now again, I'm going to use the variable x in this case. So I have cosine squared x over cosine x. Okay, now I have cosine, this one squared, this is cosine, so I can reduce this to just cosine x. So we've simplified that. Now with this is just like having x squared over x and simplifying it that way. Alright, now here I've listed the identities that we have so far again, and this time we have this. Now, I have 1 over cosine x. Now I may replace that with secant, but I'm going to hold off on that. I'm going to look at this squared part right here. Now in the last one, I'm going to look here, and what I'm going to do is, we've already done this a couple of times, but I can replace that cosine x squared. Cosine squared theta is equal to 1 minus sine squared theta. So what I can do is replace that for all of that. So I end up with 1 over cosine x times cosine over x squared. Okay, that's over 1, so I can reduce again, and so we end up with a cosine x. Now they won't always end up with cosine x, but in these two cases they did. Alright, now with this one, I look through it and I see cosine squared. Now there may be a temptation to try to replace it with 1 minus sine squared, but typically we don't do that until kind of like the last, since we have this sine with it as well. So the first thing I would do is I'm looking here at tangent, okay, and I want to see if something cancels out. So I'm going to say cosine times sine over x over cosine over x. Because remember over here we're just using this identity. So we're replacing tangent with that. So we get that. Minus sine x cosine squared x. Well, what happens to our cosines here? Well, they reduce. So we get, now we have sine x minus sine x cosine squared x. Now, if we look in here, we notice that both of these have sine in it. So I'm going to factor that out and see if I don't end up with something that looks like something over here. So I'm going to factor out sine x. And when I do that, I'm left with 1 here minus, okay, I factor that out, that's 1 as well, but then we have the cosine squared x with it. Well, 1 minus cosine squared, we've seen before that I can replace that with sine squared, because if I manipulated this like we've done in class, cosine squared is 1 minus sine, well, excuse me, we're wanting sine by itself, so it would be sine squared theta is equal to 1 minus cosine squared theta. So what we can do is replace this with sine squared. So we're going to have sine x times sine squared x. So I'm just going to, I'm multiplying those. That's the same as multiplying x times x squared. Add your exponents. So we'll end up with sine cubed x for that one. Alright, let's simplify another one of these. Now we don't have any squareds in here, so again, I'm not going to deal with these yet. I may or may not need them. But here, I'm going to go ahead and write cosecant and secant. I'm going to write them in terms of sine and cosine. So cosecant is 1 over sine. Secant is 1 over cosine. Okay. So actually we could use that as one fraction, which may make a little bit more sense. So I'm just going to write that as 1 over sine cosine. Minus, now this is cosine over sine. Alright, so where am I getting those? I'm getting them from over here. So cosecant I replace with 1 over sine. Secant I replace with 1 over cosine. And then cotangent I replace with cosine over sine. Well, if I look, they don't have the same denominator. I've got sine, cosine here, and I got this sine here. So I need a cosine here. So I'm going to multiply this by cosine. Okay? So when I do that, I end up with 1 from here. Okay? And then I can write it all underneath one fraction because I got the same denominator now. Now I've got cosine times cosine, so that's going to be minus cosine squared. Theta in this case. Now remember, we can replace this with sine squared. So we'll have sine squared theta over sine cosine. Alright, well, one of our sines is going to cancel out here. So we're left with just 1 there. That cancels. So we end up with sine over cosine. And we know sine over cosine is tangent. So we've simplified that. Now again, with this, the 1 minus, if you're still not seeing that, I subtracted sine from both sides here so that I get cosine squared theta is equal to 1 minus sine squared theta. So I'm taking, I did it again. Anyway, that it can be that, or in this case, what we needed was sine is equal to 1 minus cosine squared theta. So I can replace this with sine squared.